Hello everyone, this is Sandeep Chittur and this is a small presentation showing my how I've gone about doing my poster. The topic of the poster is text analysis and content categorization of airplane crashes using SAS Text Miner and Content Categorization Studio. I apologize for not using the tools while demonstrating this, since I have used both the text miner and content categorization studio and interactively improved the results, so I'm not able to demonstrate it together in a single presentation. Instead, I'm demonstrating the whole project through a PowerPoint presentation. I'm the author of this paper. My co-author is Raja Punati, and both of us are from MS in MIS from SAS and OSU Data Mining Certificate, Oklahoma State University. Our faculty advisor is Dr. Gautam Chakraborty. Before I start off, I want to thank Analytics 2015 for giving us such a great opportunity. Now, before I get into the topic, I want to reveal few amazing facts about the airplane crashes. If you look at this, MH307, MH17 and AH507, these three flight disasters alone caused death to 600 plus people in 2014 alone. 1320 is the number of casualties that have occurred due to airplane crashes in the whole of 2014. 111 are the number of crashes that have occurred in 2014. 88 are the number of flights that have gone missing from 1950. Isn't that scary that even in 21st century, like MH307 in 2014, a flight can go missing? 7,000 are the number of flights that are there in the sky at any point of time. 10% is the annual growth in passenger air traffic every year. 59 million are the number of international and domestic departures that have occurred in the whole of 2014. Now, why this topic? The main motivation behind this topic is to analyze airplane crashes. I mean, I have traveled through aircraft so many times, and listening to all these disasters that have caused death to so many people, it's quite scary. Because if you look at this graph showing the number of crashes and deaths by year from 2000 to 2014, the number of deaths have actually increased to 1328 in 2014. In fact, this is the 10th highest. This is the highest since the last 10 years. The previous highest was 1463 in 2005. Now, what did I do in this poster? First, I have identified three authentic websites which have airplane crash records. Using the web crawler in the text miner, I have extracted all of these 2000 crashes and made into a single corpus of 2000 observation, where each observation is a record by itself showing the airplane crash. In order to see if there is any trend over the years, I have divided these into three datasets. First dataset from 2000 to 2004, second dataset from 2004 to 2009 years, and the third dataset from 2010 to 2014. After dividing this into three datasets, I have developed concept links for the three datasets. It is quite interesting that all three of them are significantly different. In the first dataset, in the left corner, words like final approach and control co-occur with the word crash on a relatively high basis. In the second dataset, in the right corner, words like control, visibility and error co-occur with crash. In the third dataset and in the bottom, words like height, altitude, control, burns co-occur with the crash dataset. Now I have after initially looking into the default text topics that are generated by the text topic node in SAS Enterprise Miner, I have defined few terms and made user defined text topics. Basically, there are four user defined text topics. These four are the four major contributory causes for airplane crashes. The first is mechanical failure. The terms in this are crack, structural failure, rudder, wing. And the words in sabotage are bomb, hijack, explosion. Words in weather topic are fog, ice, thunderstorm, cloud, heavy rainfall. And the words in pilot error are disregard, altitude, altimeter, etc. Now, if you look at the distribution of these four text topics over the three datasets, it's quite interesting. In the first dataset, in the left, you can see that the highest percentage of crashes are due to mechanical failure, that is 38% of them. closely followed by pilot error, which is 33%. In the dataset 2, in the right corner, the highest percentage of errors are due to pilot error, which is closely followed by mechanical failure. In the third dataset, in the bottom, the highest percentage of errors are due to pilot error. Now, mechanical failures have significantly decreased. Over these three datasets, as you see from 2000 to 2014 years, the percentage of crashes occurred due to pilot error have increased from 33% to 47%. That is quite a significant increase. The percentage of crashes due to weather are almost the same, whereas the percentage of crashes due to mechanical failure have come down quite a bit. After this, I have built predictive model first in TextMiner in order to classify each of these crashes into their contributory cause. For the modeling purpose, I have used the 2000 records dataset as a corpus and divided into 70% for it for training and 30% of it for validation. Now these are the statistics of the rule-based model generated in TextMiner. The misclassification rate is 36.52 on the validation dataset, which is quite satisfactory. I felt this could be further improved. Now, in the bottom, you can see the rules that are generated by this rule builder node in TextMiner. Now, these rules are saved as a text file to be used later. After this, I create a hierarchy and took all the data into SAS Content Categorization Studio. First, I built statistical model. The statistics reveal that the categories like weather and mechanical failure perform pretty poorly, and there is significant improvement to be done in this one. Categories like pilot error and sabotage were pretty satisfactory. If you see at the percentage of pass and fail documents, the percentage of documents that failed in weather are significantly high, and also in mechanical failure. What next? Now what I did was I imported the rules that were generated in TextMiner from the rule builder node in TextMiner. I imported into SAS Content Categorization Studio and initially built models. So after the rule-based models were built, I went and interactively saw how a particular document passed or failed in the category. It is quite interesting feature I feel in SAS Content Categorization Studio, where I can view each document as in why it failed in a particular category. By doing this, we can understand few words that need to be incorporated into the rule-based model in order to increase the efficiency of the model. You can see here a particular document passed in mechanical failure, and words like in-flight and structural failure appeared because it appeared in it. In that way, I incorporated more words into it in order to increase the efficiency of the models. Let us see the model comparison of all these models. First, the rule-based model in TextMiner was pretty satisfactory with a misclassification rate of 35.22. Next, the statistical model built in Content Categorization Studio. The misclassification rate is 29.48, which is lesser than the rule-based model in TextMiner, but still it can be improved. In the third model, where rule-based model was generated by Content Categorization Studio, the performance was pretty bad. It was 41.34%. Now, in the fourth model, where I use the rules from TextMiner to improve the efficiency of the rule-based model in Content Categorization Studio, the misclassification rate came down to 19.45%. What are the results that I achieved from this? In this, I could successfully import the rules from TextMiner, models built in TextMiner, to improve the efficiency of models in Content Categorization Studio. The misclassification rate reduced significantly from 35.22% to 19.45%. Majority of the accidents are caused due to pilot error and bad weather. 70% of them. It is quite significant. If you look at the crashes caused by weather, words like thunderstorm and icing are the major contributory causes. If you look at the crashes caused due to pilot error, the major contributory causes are altitude and disregard to flying procedures. Structural failure, wing failure, and engine loss are the primary factors causing mechanical failures in airplanes. The future scope of this project can be increased by incorporating more variables like the experience of the pilot and other pilot related variables to do in-depth analysis on crashes caused due to uh, pilot error. So as you saw in this project, I could successfully use both text miner, content categorization studio. Also, I could combine both of them to increase the efficiency of my models built for text analysis and content categorization of airplane crashes from 2000 to 2014 years. I would like to thank Analytics 2015 for providing us a great opportunity, and I also want to acknowledge my professor Dr. Gautam Chakraborty for his continuous support throughout this poster work. Thank you.